Hi, this is going to be a quick follow-up video to the 2400 stereo video that I posted recently. After I got done shooting the other video, I left the equipment on and playing because when you repair equipment like this, you really have to give it some time and let it play and to make sure that it's all going to work out all right. Of course, you want it to be the very best that it possibly can be when you send it back to the customer, and the easiest way to do that is just leave it set up and let it play. And since this is a more elaborate setup here than your average NuTone intercom master station, it's a lot of work to take it all apart, put it all back together, so it's easier to just let it sit and let it play. So after the end of the last video, I left it playing at the shop for about 6.5, 7 hours, and at the end of the day on the way home I stopped by to check on it. One of the things I noticed was something had changed slightly in it, and I found it a little bit puzzling. When you work on any kind of audio equipment, especially when you work on amplifiers, one of the things you don't want in the set is you don't want any kind of little spurious background buzz or hum or any kind of noise on the system when no sound is actually being played. It's perfectly acceptable to have a little bit of white noise from the amplifier. White noise is the sound that an amplifier makes when it's turned on and it has speakers connected to it, but there isn't actually any signal being fed into it. It's just white noise. It's one of the things that I'm very aware of, and it's one of the things that I check for and look for all the time when I work on sets like these. It's not as much of a problem in solid state sets for the most part. It's more common in tube sets, and it happens in tube sets because you can have components that are out of specification or that may be noise. You can have noisy components, you can have resistors and capacitors that become noisy. We know capacitors aren't a problem in here because they've all been replaced, but you can get a noisy resistor sometimes and something like that, and it contributes to that annoying little bit of hum or buzz that you hear. The other problem with sets like this is a fairly compact chassis. There's a lot in here, and there is line voltage that comes into the on-off switch here, and you've got wires that carry 110 from the wall plug and power the transformer and so forth. And if they're not in their right locations, ideally when this was designed, they were supposed to route wires away from areas that would be susceptible to like 60 cycle line hum and things like that, and for the most part they did. Sometimes you can actually get a noisy transformer, but that's not really very common. What I noticed yesterday at the end of the day after it had been playing for 6.5 hours was when I shut the input off from the tuner and listened at the speaker very carefully, there was the littlest bit of buzz on the system, and that wasn't there before because it is something that I checked for. I thought it was kind of unusual, and I thought, well, I'll look at it again tomorrow, which is today, and see what's up with it. And I shut it all off at the end of the day and went home. I stopped by here this morning early before I went to the office, turned it all back on so it would warm up, let it run for 3.5, 4 hours before I got here today, and I figured I would do a little poking around to see if I could figure out what had changed. Now, the thing I noticed this morning was when I first turned it on, it was clean, it was quiet, there was just a little bit of white noise out of the speakers, no buzz or anything like that. When I got here this afternoon, a little bit of the buzz was back. And so it's something to do with as it heats up or warms up and after it's run for a while. And I thought that was kind of interesting because it really didn't show any signs of that. Here's how we work on this. This is what we do. So let me explain the setup a little bit and then how you look for a problem like that. So over here I have this is an auto transformer. It's a Variac. A Variac is an isolation transformer that it has adjustable voltage output. So the output, the voltage to the amplifier, the way it's powered is consistent, and it isolates it from the mains plug over here, so when you're probing around you're not blowing up your oscilloscope and things like that. I have it connected to an old Simpson 390-2 watt meter which shows the line voltage. It also, you can measure the watts and the amps that the amplifier is drawing from the Variac. It's just a handy tool. Those two things go together really well for a diagnostic tool, and I'm going to do a video about that later on. Finding noisy components. You saw what this looks like in the other video when it's more opened up, and it's, you know, it's sort of a maze of wires and components, and it's really kind of tricky. So you need something that's meant to look for noise in a device like this. And what I have is, this is my Heathkit model IT12 signal tracer, and this is an old school thing. This is from the mid or late 60s. This belonged to my great uncle, who was in the radio and TV repair business in Omaha, Nebraska. When he retired and closed his shop, he had a bunch of stuff he didn't need anymore, and he sent it all to me. I've had this for a long time. This is in good working order, and what this is, it's a very, very, very sensitive probe and amplifier, and it can pick up noises in electrical circuits. It can be in the actual, you can touch it to the wires, you can put it next to components, and the probe will pick up the sounds and the signals in the circuits, and you'll hear it out of the speaker here. And to give you kind of a quick, easy demonstration of how this works, this is turned on and it's warmed up. So we're going to turn up the volume, or the gain on the amplifier. We'll put it at about 50%. Now, everything here has been on for a while, and the tuner is, while the output of the tuner is switched off, the circuits are all active, and I have it tuned to an AM station and an FM station. So we'll turn this up a little bit, and if we take the probe, and we're not going to really touch anything, we're just going to probe around different parts inside the chassis. Let's do it this way. It helps if you turn the speaker on. Now, see, very sensitive. We'll pick up all kinds of noise. If we put it in here, you can hear the AM station. And I'm not touching anything, I'm just holding it near one of the tuning coils. And experts agree they'll continue to rise. And it picks it up. And if I move it down over here, I wasn't actually touching anything. I was holding the probe tip inside the area that's one of the IF tubes for the FM tuner. So it's a very, very sensitive probe, and with an amplifier and a speaker, and it allows you to find signals as you move things around. For instance, that's the 60 cycle noise from the 110 line that comes in from the plug, and it goes through the fuse and so forth. So it's a good tool. It's an old-fashioned tool. They don't really make things like this that much anymore, and it's a good old-fashioned type of tool because we're working on old-fashioned equipment, and that works out really well. How does this work out for the amplifier? Well, it's basically the same idea. You can probe around, and we'll turn this back up, different components. And let's say, for instance, there's a little DC buzz on some rectifier diodes, and you can probe around on resistors. And if you find one that when you put the probe near the resistor, for instance, if you start to get a little bit of buzz, maybe you've got a noisy resistor, and then you can move around the area, and it's sort of a hunt and peck kind of thing, but it's actually pretty fast. You know, there are 85 some resistors in this set, and they're all in this giant tangle, and it's kind of hard to do it with a multimeter, and you've got to probe and not short things out because you have to do this live. This is turned on and it's hot. There's voltage in here. This is a really easy way to do it because you can just sort of sweep around with the probe looking for noise. And when I did this morning, I didn't find any noise. I didn't find any noisy components. And I've found a lot of noisy components in the past, and it takes a little bit of time. You might spend 10 or 15 minutes doing it, but usually you can find that one resistor that's starting to fail, and it's gotten noisy. It needs to be replaced. So I did all of that and I didn't really find anything that to me seemed like it was a problem. And I was thinking about it. I don't remember exactly what I was doing, but I think I was going to shut it all off. And when I leaned over here and I was going to switch off the auto transformer, I noticed something interesting. My auto transformer, which had been on for 4 or 5 hours at that point, it was a little bit warm, which you would expect, but I noticed there was a little hum in the auto transformer. And I thought that's kind of odd because I've never noticed that before. But on the other hand, it's not usually on for that length of time very often, just on sets like this sometimes. And I never really noticed that before, and I thought that's kind of odd. What I did was I shut everything off. I unplugged the line cord from the auto transformer that feeds the amplifier, powers the amplifier, and I plugged it in the wall plug on its own, bypassing the auto transformer and all that. Let the set warm back up, turn it back on, and it was gone. The buzz was gone. It was nice, clean, white noise out of the speakers. Apparently the auto transformer's got a little bit of going on in it, and it was feeding a little bit of buzz into the power line, into the amplifier, and it was coming out the speakers. That's one of those kind of things that can really trip you up if you haven't ever seen it before, and it's not something that you really would have considered to be a problem. I've had this auto transformer for probably, I don't know, 25 years. I've never had a problem with it before, and it never would have really occurred to me that it would have caused a problem like that, but apparently it can. So it's just something to be aware of. So I just wanted to kind of go over a little bit. You have to be really, really particular on sets like this because there's high expectations when you rebuild something like this, and everyone's attention is going to be really laser focused on it, and you don't want any little glitchy things to go on with it so the customer is not like totally thrilled with the whole thing. Anyway, just a little quick video about a surprise that came up along the way. I hope you found this interesting and perhaps helpful. If you work on this kind of equipment, get something like this. They're not terribly expensive. You can buy them, you can find them on eBay sometimes, or you can buy them at ham radio swap meets and things like that. Sometimes they need to be rebuilt a little bit because they're kind of old and if they've been used or abused a lot. This one's actually in pretty good shape. It's kind of cool. It's got a eye tube down here, so you got audio and you have a visual indication of what's going on. I'll do a video about this sometime in the future. If you work on tube equipment, highly recommend something like this. It makes your life a whole lot easier. I hope you found this interesting and perhaps helpful. If you did, please give it a big thumbs up on YouTube because that always helps. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell or on the wheel, put in your email address, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.